Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. Today we are going to see very basic information about these circuits. In this video we are going to see what is Kirchhoff's current law, what is Kirchhoff's voltage law, and we're going to see the procedures to solve mesh analysis problem. Right? To start with, we will start with Kirchhoff's current law, where Kirchhoff's current law can also be called as mesh current law, and it can be, in short form, it can be called as KCL. According to Kirchhoff's current law, the algebraic sum of currents meeting at any particular junction or a node in any electronic circuit is zero. We can also say, in other words, that is the sum of currents flowing towards any junction in a circuit is equal to sum of currents flowing away from the junction, right? So at any particular point, the algebraic sum of current will be zero. That is called as Kirchhoff's current law. We can mention it as KCL. And if you take this as an example, say for example, you take 5 conductors, current carrying conductors, right, meeting at a particular junction, and you can see here current I1, I3, and I5 are entering the node O, whereas I2, I4 is leaving the node. So we can write it like this way, that is current entering the node is I1 plus I3 plus I5, whereas leaving the node we can consider as negative sign. So it can be represented as minus I2 minus I4 equal to 0. So we can add it, we can reform it as simplified as I1 plus I3 plus I5 equal to I2 plus I4. So which means current entering the node is equal to the current leaving the node. Right? So that is sum of incoming currents is equal to sum of outgoing currents. Right? This is Kirchhoff's current law. And we'll see what is Kirchhoff's voltage law. Kirchhoff's voltage law can be mentioned as KVL in short form. According to Kirchhoff's voltage law, in any closed circuit, in any closed mesh, or even we can call it as a loop, right? The algebraic sum of voltages taken around is zero. That is, if you take any closed circuit, right? In that circuit, the algebraic sum of voltage will be zero, right? That is, the in any closed circuit or mesh or loop, sum of voltage drop equals to sum of voltage rise. Say for example, if you take this particular circuit, right? If you take this particular circuit, this is one particular mesh and this is another mesh, right? If you take this particular mesh, you can see this voltage V1, right? That is a voltage rise, that is from lower potential to higher potential. So there is rise in voltage, right? And you have R1 and R2. So in this particular mesh, this V1 will be equal to, right, the voltage drop across this R1 and R2, right? So we can mention it as VIR1, V is equal to IR1 and IR2. We can mention that, right? So if we consider this as current I1 and this as I2, right? So we can write it this way: I1 into R1 plus I1 to R2. Just consider this mesh alone, right? And so if we consider this alone, this mesh alone, right? The voltage drop of these two resistors must be equal to this particular voltage rise, right? So if you take any particular mesh, the algebraic sum of voltage must be zero, right? And if you take this mesh again, right, this mesh, then again this voltage must be equal to the voltage which is dropping across R3 and R2, right? So don't get confused. I'm taking only this particular mesh, right? Because if you consider this mesh, we have to write this as I1 minus R2, right? So for your explanation, I have just explained you what is Kirchhoff's voltage law. If you take any particular mesh, in that mesh, right, the sum of currents, sum of voltage will be equal to 0, which means the voltage drop will be equal to the voltage rise, right? And Kirchhoff's voltage law speaks about voltage, whereas Kirchhoff's current law speaks about the current. Right? This is very important laws in circuit. Right? Now we'll see about mesh analysis. Right? We'll apply the KVL in mesh analysis. Right? So we will find out the procedures for mesh analysis. How to analyze any particular circuit. Right? So say for example, if this circuit is given, right? If this circuit is given, how to solve this particular problem? We have a lot of procedures, right? And my dear students, I'm explaining you here one procedure. That is, we will follow certain rules and regulation. I'll tell you what is the rules that we are going to follow. But this rule is not like it is the only rule for mesh analysis. You can follow any rules, but don't get confused by saving lot of other rules, right? Uh, in some particular books, it will be given as plus and minus will be different, right? Whereas in some book, it will be considered in a different way. So different procedures are followed. So my advice here is, if you follow one procedure, stick to it. If you see three or more procedures, then you will get confused, right? So first thing is, in our analysis, what we are going to do is we are going to consider the current direction for all the mesh is same direction, right? Whatever may be the question, the first thing what you have to do, you consider the current direction as same for all the meshes, irrespective of the voltage sources given. Don't worry about what is voltage sources given, right? So now I consider all the mesh as clockwise direction. That is the very first step you have to do. And you mentioned this as I1 and this as I2, right? And now next step is you have to assign plus and minus for the resistors, right? Now I'm going to give plus and minus. Whenever you approach any particular resistor, give plus sign, and if you're leaving that resistor, give minus sign. So if you see here, it is plus and minus, and this is plus and minus, and here it is plus and minus, right? Now I'm going to write the equation. So in mesh analysis, like only while writing the equations, you have to be very careful. Like once you write the equation, it's all about mathematics. You have to just solve that equation and you have to find out I1 and I2. Okay. So now, how to write the equation? Now consider this mesh. I'm going to consider the first mesh. B, C, F, A, B. B, C, F, A, B. I'm going to start from here, right? So if while approaching here, it is here that's just R1 is given, no values is given, so R1 alone is given. So I'm going to write R1, right? So it is plus R1, so it is plus R1 actually, right? And coming here, it is again plus, so it will be R2, R2, and here in this mesh, if you see this resistor, it has both I1 and as well as I2. Always consider I1 is greater than I2. I1 is considered as I2. And similarly, if you're going to write I2 and I3, always consider I2 as greater, right? And follow the same procedure for all the problems, right? So now, if you take this I2, then you have both I1 and I2. So I'm going to write as I1 minus I2, right? So I'm writing the expression for this particular mesh. So I have to consider only I1 here. So this R2 contains both I1 and I2. So I am writing it as I1 minus I2, right? And again, now it is minus. We are approaching minus. So it is minus V1. We are approaching minus V1, right? So because we are approaching minus here. right? That is equal to 0. Now, you can simplify this expression, correct? How will you simplify? R1 plus R2 into I1 minus R2 into I2 minus V1 equal to 0. This is the expression for first mesh, right? Now, consider the second mesh. Second mesh is C, D, E, F, and C fully. Right? I'm going to start from here. So how will you write? So it is, we are approaching from plus. So it is R3, R3, and we are approaching here. It is plus here. So it is plus V2, and here we are approaching minus. So it is minus R2, minus R2. And again, you will write here R2. You know that this I1 minus I2. Right? That is what we have written already. So it is minus I1 minus I2 is equal to 0. Now you simplify this expression. R3 plus V2 minus R2 into I1 minus R2 into I2 equal to 0. And this is expression 2. This is equation 2. And this is equation 1. And if you solve this expression, we will find out what is the value of I1 and I2. This is the procedure for mesh analysis. And I'm repeating again, if you want to follow one procedure, follow the same procedure. Say for example, if you see another procedure, right, this direction of current will be this side, and they will put minus sign here. Like that, you have lot of procedure will change, right? But if you follow one procedure, go with that, right? And now whatever I said here, that is what I've explained here. So you consider this mesh BCFAB and this CDEF, right? And assume that current in same direction I1 and I2, and always consider I1 is greater than I2, right? And whenever you are approaching any particular resistor, give us plus and minus. And while writing the expression, writing the equation, always consider which sign you are approaching. If you are approaching plus, put plus. If you are approaching minus, put minus. So you can see here, this is the expression which we got, right? And similarly, this is the expression which we got, right? Already, right? So if you solve this expression, we will be able to find out I1 and I2. And in next video, we will see in detail about solving the problem using mesh analysis with the same procedures, right? So today what we have seen is we have seen what is Kirchhoff's current law, what is Kirchhoff's voltage law, and we have seen basic procedure for mesh analysis. I believe this video will be very useful for you. Thank you, my dear students.